Good morning. Can everyone hear me clearly? Right, good. My name is Dasith, and welcome to Modern Authentication, a story of identity set amongst the clouds. A bit about me, I'm a consultant working for Redify. Part of what I do is going to different clients and help them solve different technical problems and help them build solutions. And something that's always cross-cutting and that comes up often is this problem of solving identity and authentication. And there's been a few cracks at this over the last few decades, but I want to cover more modern approaches to this, and hopefully at the end of this talk you can take home something about some modern approaches, and hopefully I can spark some interest in things like OAuth and OpenIdConnect. Jumping straight into the agenda, I want to cover the basics at the start, what authentication and authorization mean in this context. We'll look at what a claims-based identity is and the parties involved in a normal authentication flow. Then we'll look at things like JWT and SAML tokens. I'll dive in as we go through them. Then finally, we'll look at OAuth and OpenIdConnect and how these things supplement each other and some of the flows you can use and some of the concepts around OpenIdConnect. My aim is to introduce you to the concepts. So if you find any of the flows familiar with what you're currently doing, or in future problems you have, you know where to go in terms of the right workflow. So starting off, identity and trust. These are some of the definitions for the things we are going to discuss today. So think of identity as a set of attributes or properties about a subject. Authentication is the act of verifying said attributes or attributes or properties. Authorization is a function of giving access to something based on a set of rules you have. There are two types of token. There's two types of access tokens we'll look at, to users rather. So there's access. So the first type of token is an access token, which is a key that gives you access to a resource. And the second type is a identity token. Think of it as something like a driver's license, where it's got a set of claims and it's used to prove your identity. Now, moving on to the traditional approach of application development. Before I go there, I just want to know how many of you have developed an application that had a database with a user table in it? Show of hands. Right, most of them. Well, very good. So this is a very simple approach. You have the user's information, roles, etc., saved in a database table somewhere, and you look it up when the user provides the credentials. And finally, you verify and give them access to resources based on that. It's a simple approach, and you control everything. But what this introduces is an identity store that you have to manage. Not something that you want to do in the long run, because there are password management, hashing. There are so many security policies and best practices you have to adhere to. And if you're not working for a big company that has a lot of resources, over time, you're not going to follow the best practices and you're open to security risks. The other thing not many people realize is every time you do your own identity service or identity store, you introduce this concept of identity islands. From the user's point of view, every time they have to go into a new service or have to use a new service, they need to sign up with credentials, and after a while, they start using the same credentials everywhere, because everyone's human. Not everyone uses a password manager, even though we like to think that they do. And the risk of this is weakest link breaches and a malicious actor gets hold of your credentials, and they can use this in other services as well. So the attack surface got a lot bigger because the user was using the same credentials, and we implemented a pattern that encourages that. Last year, there was a big breach of 1.4 billion passwords or credentials. And the sad thing is, this wasn't the first, it won't be the last. So we need to take this into account as we develop more solutions or applications and leverage a more scalable or more secure way. And luckily for us, the real life is a good place to start. And I'm going to use this example or this motive going forward because I'm a big believer of learning through examples. And let's see how this problem of identity is solved in the real world. So imagine our old mate Dilbert wants to hire a rental car, goes into the rental office. Amy, a helpful rental manager, wants to verify the identity. Now, this is a common enough scenario, but one thing to remember here, one fundamental difference to our traditional application approaches, they don't have their own identity store. They leverage an existing trust relationship with a driver's license provider or a passport provider. Now, this is very good because they only have to have that prerequisite, something that was there even before Dilbert walked in the rental office. They had this trust relationship, which now they can use to almost verify anyone who walks in the door. Now, this happens through a mechanism called claims-based identity. So a claim is made by someone. Someone making the claim is called the identity provider. And the thing that the claim describes is called the subject. Now, if you trust the identity provider, you can trust the claims they make about a subject. And this is the principle we carry forward. Let's take a look at a driver's license as an identity token. So it's got a few claims, the name, address, date of birth, etc. And also it provides who the identity provider is here. So in this case, it's Vic Roads. And the verification process happens through a holographic logo. So this tells the person interested in the driver's license that this hasn't been tampered with. And it is indeed a actual driver's license rather than a fake. Now, the business might have its own rules about who can drive a car or rent a car if you're 21 years or older, but they use these claims to assert those rules and then give access to the resource they want. Now, I touched on a bit about how this problem of authentication has been something that our industry has been trying to solve for a few decades. As a result, there's been different standards and protocols over time. And as a result, different contexts have provided different names for the same concept. For example, a user will be described as a subject. I'll try to use the word subject as we move on, but whenever I can, I'll try to make the connection to a user. Now, the application in the middle has got two parts, the relying party or the client, which is the rental office, and the resource we were trying to protect, which is the car. Then the identity provider and the authorization, again, interchangeable terms. I'll share the slides afterwards because I realize there's a lot of information here. But just remember, there's a few interchangeable terms. If you're reading any documentation online, this will come up, but they effectively mean the same thing. Now, let's contrast our modern approach to the real-world example we looked at. And it starts with a trust relationship with a relying party, an identity provider. And the first step the user does, or the subject, is logging to the identity provider, which returns a token. Now, this token, think of it as the driver's license. We then provide the driver's license to the application or the relying party in the middle, which verifies the token and gives the resource they want. Just to recap what we looked at, we looked at what identity authentication authorization is, the principle of claim-based identity and how to leverage existing trust relationships. And we looked at a few interchangeable terms for a user, relying party, and an identity provider. This takes us to part 2, which is tokens. Now, anyone who's been listening for the last few minutes can have a genuine question. What's the difference between a password and an access token? This is a very, very good question, because they both effectively do the same thing, give you access to a resource. But the major difference between a password and access token is the scope. A password can be thought of as a master key. Now, I'm a very paranoid person. I don't want to give a master key out to anyone. Whereas a token is very narrowly scoped. Usually a token is for a special task and also has a time constraint attached to it. So even if something were to go wrong, the damage is very limited. As a result, it's the preferred way to give access to something. There's two ways or two types of tokens. One is a self-contained token. The one we looked at, example with the driver's license, is a self-contained token. If you want to use a driver's license to verify someone's identity or give access to something based on that, you don't have to call VicRoads. Everything you need is there. But there's a second type, which is a reference token. Think of it as a reference number. A good example is like a Visa number, where if you want to apply for a credit card while you're on a visiting visa or something, you have to give them the reference number. They can check the immigration office or something like that to verify that is indeed a valid reference number. So this kind of flow is more secure because the token never gets handed over directly. It's the reference number, and the relying party has a back-end call with the identity provider. Now, the two modern types of tokens that I want to touch on are called SAML and JWTs. So the SAML stands for Security Assertion Markup Language. This was very popular during the ages of SOAP and XML-based web services. And enterprise loves this because it provides a framework or a protocol for authentication, authorization, and everything in between. It's like a Swiss Army knife. It can handle everything. But as a result, what it is, it's very heavy. If you look at a bit of the history, you can see it starts around 2002, early 2000s, and goes to the mid-2000s. This is the prime time for web services and SOAP services. And because it's based off of XML, it's quite big. Now, don't worry if you don't understand any of this. There are libraries built on top of SAML tokens that you can use. You just need to understand the structure. So a SAML token has this concept of assertion, and the assertion has information like the subject, this is the part it's describing, some conditions which apply to this assertion, and a thing called authentication statement, and some attributes. So think of attributes as name, address, basically claims. The SAML tokens, because they're very heavy, doesn't cater well for modern web applications because we utilize HTTP, and this yields us to JWTs, or JSON Web Tokens. Now, whereas SAML is a full framework for solving authentication and authorization, JWTs are nothing but a standard describing JSON-based tokens. So the scope is very narrow, but the use cases for this, as a result, are very extensible. A JWT has three parts to them. There's a header, which describes the signing algorithm, which we'll go into later, the payload, and then the signature. The signature is something that is used for tamper-proofing the JWT. Now, because this needs to be transferred over HTTP and part of URLs, or as a part of a query string, it looks like this. Now, don't worry, it's just base64 URL encoded, JSON information there. The three parts are the header, which is basically that JSON payload, base64 URL encoded, a payload, and then the signature. So think of the signature as like a wax seal you put on a letter. If the parts above it are tampered with, the signature gives you a way to verify that it has been tampered with, or if it's not, it has not been. Let's look at an abstract way of constructing a JWT. So you start with a header and a payload, both JSON, and you pass them in, you first base64 URL encode them and concatenate them with a dot in the middle, and you take that and you pass that into a signing function. Now there are two types of signing functions for a JWT. It can be a shared key algorithm or a private asymmetric private public key algorithm. For the demo purpose, let's assume it's a shared secret signing algorithm, and you sign the payload and the header with that algorithm using the shared secret, and you get a signature. And once you get the signature, you base64 URL encode that, and you concatenate all three parts with a dot in the middle to signify where one ends and the other one starts. And once you have a JWT, the other side, the receiving party, needs to verify this. How they verify is, you get the first two parts of the JWT, you pass it to the same signing function. Remember I said, I showed the header has the signing algorithm, so the party receiving it knows which algorithm the JWT is signed with. So they do the same thing with the shared secret they have, and they generate a signature for themselves. And they now compare the signature in the JWT to the signature that they generated. If they match, then it ensures that the JWT hasn't been tampered with. Now this is the way the JWT can be verified without the relying party having to call the identity provider each time. So they can be in a disconnected state and still be able to verify something. This is very cool and scales very well, and that's why the modern authentication systems love it. Now let's compare a JWT to a driver's license. The JWT I have there is something from an OpenIdConnect endpoint from Azure AD, and it's very cool how they match up. For example, they've got the signing algorithm key, which is similar to a holographic logo on the driver's license. It tells you how to verify that identity token. Then there's a issuer claim. So issuer is the unique name that identifies the issuing identity party. In this case, it's similar to VicRoads. So it helps the relying party ensure that it's from an issuer that they trust. Then there's expiry date. Remember how I said tokens have a time limit associated with them. So this expiry tells them when to use it and when not to use it. There's also some claims about the name and address or whatever's in the context of that transaction. One thing different, or the one thing the driver's license doesn't have, is the concept of an audience. Now think of an audience as a person who this piece of identity token is intended for. And if you're not the audience of an identity token or a JWT, what the standards tell you is to not trust it. So this is even better than a driver's license, because driver's license is open-ended. Anyone who trusts VicRoads can use it. But in terms of a JWT, or especially OpenIdConnect, it's very narrowly scoped to a particular audience. Now, this brings us into part 2, and recapping what we learned. We compared passwords and access tokens, and why we prefer access tokens. We looked at a SAML token, when a bit about the history of SAML and why it was popular and why it's still used by enterprise. We looked at the makeup of a SAML token. We didn't dive too deep because JWT should be our focus today. We looked at how to create a JWT and how to verify it as well. This brings us to part 3. This is where we start making use of our concepts of identity, claims-based identity, authentication, and those JWTs. OAuth as a standard is nothing more than a set of protocols of how you obtain a key. Now, compare this to real life. If you have an admin room in your office or a floor that you need to get access to, you go to the building manager, you sign a form, and then you have to go through certain steps to get a key. And this is the same thing that OAuth dictates. It's a set of protocols based on the client. So it could be a mobile application, a web application, a single page JavaScript application running on the browser. Depending on the application, it dictates certain flows. And this came about around the same time as social media giants like Twitter, Facebook, etc. were coming up. Because there were big identity stores that these services were building, and they wanted to leverage these identity stores with other third-party services. So around 2006, Twitter OpenID implementation came up with the first standards for OAuth, and the final draft was in 2007. And in 2012, OAuth 2.0 came about with some standard flows. And even today, there are new standards being introduced or extensions being added to OAuth for new things. For example, smart TVs. If you wanted to use Netflix, for example, in your smart TV, there's a flow for that. We'll dig deep into that later on. But the importance of OAuth is that it provides a standard way of using protocols or getting things like access keys. One limitation of OAuth is though it solves the problem of authorization very well, but doesn't give you a specification about how you handle identity and authentication. So when Microsoft, Twitter, and Facebook started, even Google, started implementing OAuth, they all had their bespoke protocols built on top of OAuth for identity management and authentication. What this meant was after a while, even though they were using OAuth standard, the implementation of identity was different, and it wasn't interoperable. Around 2014, they got together and introduced this thing called OpenIdConnect. This aim of OpenIdConnect is to have a layer on top of OAuth that solves the problem of authentication. Think of, if OAuth is the key, if you think of it as a way of obtaining a key, OpenIdConnect is a way of obtaining a key with a set of claims attached to it. So not only does OpenIdConnect give you a key, but also has an identity attached to it. But as a result, the standard dictates a few things. Now, I'll abstract some of these concepts. There's 3 main parties. Surprisingly, these are the same parties we've always been dealing with. There's a subject, a relying party, and an identity provider. The only thing the subject needs to do is sign up. So let's say Facebook, I need to sign up with Facebook for an account. And whenever I want to use a third-party app, I need to grant consent. I'm sure you've seen that application window come up saying, grant access to Facebook, a third-party app to read my email and full profile. So that's a responsibility of the subject. The relying party also needs to register. And this is how they construct that trust relationship with the identity provider. Upon registering, you get a client ID and a secret. And these 2 things are used to verify and maintain the relationship with the identity provider. And it also dictates that the relying party pick a right flow depending on the type of client they're developing and manage the token lifetime. So, for example, if our identity party gives a token and the token is expired, it relies on the application to ask for a new token. It won't tell you when the token is expired. The responsibility is in the middle, in the relying party. The identity provider, though, has the most responsibility. It needs to allow both the subject and the relying party to register. So Facebook allows this. And have a discovery endpoint. This discovery endpoint is something like an advertisement you post on a notice board. It has meta information about the service that it's providing. Things like the endpoints for authorization, token exchange, and user info. I'll go into that in the next few slides. And advertise about the claims that it can provide, and a few more meta information, like if it's using a public-private key algorithm, it has to advertise a public key here as well. Now, this is an example of Azure AD v2 OpenIdConnect endpoint. It's got a few parts to it. I'll go through them. There's the authorization endpoint and a user info endpoint. The details aren't important. Just know that these are the things in a metadata sample. There's a ID token signing algorithm specified. Now, RS256 means it's using a public-private key or asymmetric key algorithm. If it's HS256, it means it's using a shared key. It also has some information about the response type supported. We'll see this get used as we look at the OAuth flows and some claims that it supports. So what this tells the relying party is, these are the claims I can give you. If you get something, don't expect to get something out of this set, or be prepared to handle these claims if you get them. Now, we already looked at access tokens and identity tokens. Access token is a key, identity token is a set of claims about the user. A refresh token and an authorization code are examples of a reference token. So if an OAuth flow gives you a reference token, you need to use that to get an actual access token from a special endpoint. This endpoint is called the token endpoint. We'll look at that now. So the first endpoint we talk about is the authorization endpoint. This is the endpoint where the user logs in. So if it's Facebook, Facebook has authorization endpoint. We go there, it comes up in a pop-up. I'm sure everyone's seen that. There's a username, password field. You put that, then the consent screen comes up and we say accept. The user info endpoint is the endpoint you can get information about the user. The application can, or the relying party can pass the access token to this endpoint, and it gives a set of claims or a full set of claims about the user. The token endpoint, which we touched on in the previous slide, is the endpoint where we exchange a reference token to an actual access token. So remember that example of calling an identity provider to verify a reference number? Now this is that endpoint. If you have a special OAuth flow that gives you a reference token, you would make another backend call with that access token to get, with that reference token to get the access token. We'll look at that in a couple of slides down. So OAuth has a concept of client types. There's two main client types. There's a confidential client and a public client. An example of a public client is a single page application running on the front end on a browser. The reason it's called a public client is because you can't have secrets stored there because the source code is visible. Confidential clients, on the other hand, run in private environments where you can have secrets embedded, and you know that that confidential information won't get leaked. Now, you can see I've moved native app from confidential client to public client. The reason is, even though a mobile device is kind of its own private environment, you can't guarantee the safety of secrets in a mobile app. The third column there is for something that can't be put in either. It's input constrained devices. Think of living room devices, things like Amazon Alexa, Google Home, even your smart TV. So this is a very new type of device, and there's still discussion in the OAuth panel about how to classify these and which flows to use. Which brings us to some of the OAuth flows. The main two flows I want to concentrate today is the implicit grant and the authorization code grant. The implicit grant is the one most likely to be used in modern applications because you have a single page application running in the front end. And the single page application flow starts something like this. We've got a user, Dilbert there using a application on the browser, signifying by the rental office. Then you have an identity provider in the middle. And the thing they're trying to get access to is the web API. So the first step is you get redirected to the authorized endpoint. So this call has the client ID and the response type required. Because once signed in, the authorization endpoint needs to redirect the user back to the application. We have the redirect URL here as well. Upon successfully logging in, they'll see a screen like this, asking for the consent to be granted. And when they click yes, they get redirected back to the browser or the single page application with an access token and an ID token, depending on what they ask. And this ID token or the access token then can be used as a bearer token in the authorization header to make a call to the backend resource. And because it's a JWT, it can be validated on the backend without having to go back to the identity provider. And this is the simplest flow, but one drawback of this is it exposes the access token in the URL. So this is only to be used if you have a single page application or something where it's running in a public domain. And the source code is accessible, therefore you can't have secrets stored. Now, let's have an example of a web app, or a native app. If it's a web app, something like MVC app, PHP, Rails, something running in the back end. And here we can store a secret. And let's see how we can utilize that secret to not expose the token to the front end, but have a back channel call to get the token in a more secure way. The authorization code grant flow starts the same as the implicit flow. The user gets redirected to the authorized endpoint. This time the difference is the response type is code, whereas before it was ID token, but we still pass the client ID and a redirect URI. And it's pretty much the same in terms of the consent flow. User logs in, allows the application, and we get, this time we get a reference token. And the application then makes a back channel call. So this happens in the back end without the user being involved or the browser being involved. We pass the client ID and the secret along with the reference token. This is the reference number we were talking about before. The token endpoint, that's the important part, we pass that to the token endpoint. Token endpoint is able to validate or correlate that we gave this reference number to this client, and because we pass a secret, it knows it's the client that we spoke to before. It gives in response to that request, it gives access token and ID token. Once we have the token, it's again the same flow. You embed that in the authorization header as a bearer token. You call the backend, JWT, therefore the backend validates it and gives you access. The hybrid flow, which is a mix of both. This is used if you have a single page application as well as a backend application, and both need access token. So this is a mix because it returns the access token and ID token in the URL, but it also has a authorization code embedded for getting access token later on. You won't run into this scenario often, so that if you remember the first two, you can pretty much work out how the hybrid flow works. The next flow I want to touch on is called the client credentials flow. This is a flow used when there's no user involved. Think of a background application or a web job that's running on a time trigger. So a good example is application hitting a third-party service, getting all the users, doing a few tasks based on the information it receives and processing it. Because there's no user involved, an administrator of that resource needs to grant access to this application. And that's the first step. So once the admin consent is provided for this application, it can log in. It first goes to the authorization server, or this is the same as identity provider. Remember I said there's a few interchangeable terms. Because there's no user involved, the term identity provider doesn't make a lot of sense. Therefore, we use the term authorization server. But when you pass your credentials, as in the application has a client ID and a secret, they pass that, they get a token back, then they use the token to get the Dilbert's driving history in this example. But the important thing to remember here is that there's no user involved, it's just two systems talking to each other. Now, as we move to more modern flows of the OAuth2 spec, this is called the RFC 7523 flow. Basically, the problem this solves is backends or backend services having to call another downstream service emulating your identity. It's often referred to as the on behalf of flow. So take this scenario for an example. You have API A that needs to call API B, but it needs to call API B as if it's calling directly as the user. So it's not calling Web API B as Web API A. B is calling A as if it's emulating the user. So how this happens is API A treats its access token. So to start with, you can use the implicit flow or the authorization grant flow to get the token and once the token is received, this is where this flow comes into play. Step one, you call Web API A the same way you would with a bearer token in the authorization header, but this is where the magic happens. Web API A treats your access token as a reference token. It uses the token endpoint and passes its client ID and secret, and it gets a new token. Now this new token is for Web API B, but on behalf of the first user. So from Web API B's point of view, it's as if the application or the user is calling it directly. So this is very neat in scenarios where Web API B doesn't have to know anything about Web API A. So it's very extensible. But this is very new. The formulation of this or the standard for this is still being discussed. It's very close to being finalized. But if you have a scenario where you have these backend systems needing to emulate a user, think about this flow. The device code grant flow, again, is something very new. It's the scenario, or it's what you use if you have a smart TV, for example. I'm sure you've had this when you want to use Netflix in your home TV. So it starts with the TV sending a request to get a user code and a URL, and the TV displays it, something like this. all you have to do is get your phone, scan a QR code, which brings you to a screen like this, where you put your username and password with that code. And while you're doing that, the TV is hitting an endpoint, checking to see whether you've logged in. And when you've completed logging in, the TV gets an access token for the scope of your user account. Then it can access Netflix services or whatever, but it's effectively doing it as yourself. The reason why this happens this way is because the smart TVs or living room devices aren't very user-friendly in terms of user input. So you can't put a username password in the TV. You rely on another device to do that. Now, I don't expect you to remember all the steps. What I want to take out of this is remember the scenario and the right flow for it. And the resource owner password grant flow is when you have no other option and you want to transition into a more modern identity scenario. So you use the username and password. So that's like handing your master key to the client. It's a thing we tried to avoid before, but because this is a stopgap, this is a way of getting your legacy applications to work with a more modern identity scenario. So what the client does here is it exchanges your master key to a more narrow scoped key. So we are relying the client does the right thing. As a result, I don't recommend you use this unless there's no other choice. So there's a handy chart for picking the right flow. I'll upload the slides. You can have a look at this freely when you have time. But basically, remember, if it's input constrained, you have to use a device code flow. And if it's a public client, and it's running on the browser, implicit flow is your only option. If it's a native or a mobile app, there's authentication code plus something called PKCE. It stands for Proof Key for Code Exchange. It's well documented. And if it doesn't have an active user, you go with the client credentials flow. And for backend MVC and PHP type of apps, you have the authorization code flow. And last, no other options, you go with a resource owner password credentials flow. To recap what we looked at what OAuth is, what it solves, OpenIdConnect, how it supplements OAuth, and the concepts around OpenIdConnect and the endpoints, and how to pick the right flow for your scenario. The thing I want you to take home is that OAuth solves certain scenarios. You don't have to remember every flow, but remember that there is a flow for this, and you can use a library or a third-party tool, but the choice and the responsibility of picking the right flow for the scenario is up to you as a developer. Leverage existing trust relationships with identity providers. It makes a better user experience for the user, and it makes your applications more secure. There's some references here as to what you can do next. I'll upload the slides so you can have a look at this later on. But I'm happy to take questions if we have time. Yeah, we probably can take a couple of questions. Right. So the question is, how much trust do we have in the big companies with the identity stores to use them versus storing our own? It's a big question, and there's a gray area here. You need to look at the alternative. The alternative is having your information somewhere that you control, but how long into the future are you able to get that up to standard and keep it or audit it against the best practices? It takes a lot of resources, and you have to think about developers leaving and the company being able to maintain that identity store versus leveraging some information that's already there. So the trust is that the user is already there, we are using the information. But I think the risk in terms of how the data is being used is more for the user than an application developer. If the user's already there, they've already crossed that bridge. What we're doing is leveraging that information. So for me, it's a clear choice. I'm not a security expert, nor do I want to be. It's a very hard thing to do, and as long as I'm developing against the protocols and standards, I can be happy that I'm doing the right thing. As soon as I start storing identity information, the onus is on me to protect people's data. And for me, it's a clear choice. I always go with leveraging existing identity stores. Right. Yeah. Yep. If you're using Azure AD, it's called On Behalf of Flow. Identity Server, which is another implementation of OpenIdConnect, has that. So the thing, though, is until it's finalized, every provider has a slightly differing implementation of it. But very soon, I'm talking maybe 2 or 3 weeks, it will be finalized. And that's good because standards help us interoperate between systems. Thank you.
Yeah, can we get a huge round of applause for Dasith?